Einstein's principle of relativity. Einstein's theory of special relativity is based on two postulates that we should be aware of. The first one is the principle of relativity. The laws of physics must be the same in all inertial reference frames. So if I change a reference frame, if I go from one inertial reference frame to another, the laws of physics must be the same. Number two, the constancy of the speed of light. So remember we talked about the Michelson-Morley experiment, and the early theory basically stated that the speed of light was c only in this holy medium called ether. But Einstein's postulate is that, based on Michelson-Morley experiment, for example, the speed of light in vacuum has the same value, 3 times 10 to 8 meters per second, in all inertial reference frames, regardless of the velocity of the observer or the source emitting the light. The speed of light is constant in vacuum. It doesn't require a medium to propagate. All right. So what are the consequences of these two principles, the principle of relativity and the constancy of the speed of light? Well, we will talk about simultaneity, time dilation, and length contraction. So in this video, we will concentrate on the concept of simultaneity and the relativity of time. Now remember that in Galilean equations, Newtonian mechanics, we have a universal time scale. So when an event occurs at a certain time in one inertial reference frame, in another reference frame, it occurs at the same time. But Einstein's theory says that time depends on the reference frame. Because the speed of light is constant in vacuum, this immediately implies that time should depend on the reference frame. Okay, so let's demonstrate this with an experiment. So we have a train here that is moving with a velocity v to the right. So we label the left end A prime, the right hand B prime, and the midpoint O prime. And at time t is equal to 0, this A prime corresponds to point A on the ground, O prime corresponds to point O on the ground, and point B prime corresponds to point B on the ground. What happens is that lightning strikes A and B simultaneously. So we have lightning striking A prime A, B prime B simultaneously at this moment. So what will happen, because this train wagon is moving with a constant velocity v to the right, the light signals emitted from points A and B will reach point O, the midpoint, at the same time. Why? Because the speed of light is the same, the distance traveled is the same. So the observer at point O will report that because the light pulse travels the same distance, delta SA equals delta SP, and the time it travels it takes for the light pulse to reach point O is the same, the A and B were hit simultaneously. All right. How about an observer at O prime, that is inside the wagon? So O prime has moved closer to the event at B. All right. So for the light pulse that has struck point B, it's going to have a smaller distance to reach O prime as compared to the light pulse coming from A reaching O prime. So this is going to travel a larger distance. So O prime has moved closer to the event at B, so the light signal from B reaches O prime first. So O prime will conclude that the front of the car was struck before the back of the car, because the light signal from B has reached first, and then O prime observer sees the light pulse coming from A. So these two are two inertial reference frames. We have a lab frame, the Earth reference frame at rest, and this is another inertial reference frame that's moving with constant velocity v. However, the observers in the inertial reference frame, Earth reference frame, says A and B were hit simultaneously, and the other observer at O prime inside the wagon says B prime was hit first, then A prime was hit. So the front of the car was hit first and the back was hit next. So this is a consequence of the speed of light c being the same in both reference frames. All right. So what does this tell us? This tells us that simultaneity is not an absolute concept. It depends on the reference frame. So it's not only due to the transit time of the light pulse. The speed of light c is the same for both observers, so this immediately implies that simultaneity is not an absolute concept. So we have demonstrated this. Earth observer says lightning struck A and B simultaneously. The observer inside the train wagon says lightning struck B first, then A. All right, so let's summarize. Einstein's theory of special relativity is based on two postulates. The principle of relativity, laws of physics must be the same in all inertial reference frames. Constancy of the speed of light. The speed of light in vacuum is c, regardless of the inertial reference frame, in which inertial reference frame we view it from. It's always c in vacuum. In the material, if you remember, when the index of refraction is greater than 1, light slows down due to the finite time it takes for the atoms to absorb and re-radiate the light, the electromagnetic waves. The consequences of the theory of special relativity are in the concepts of simultaneity of time, and then we'll talk about time dilation and length contraction. So first of all, in the Newtonian mechanics, we have a universal time scale. In Einstein's theory, time depends on the reference frame. So we have demonstrated this with this experiment. Lightning strikes point A and B, and point A prime and B prime. So this happens simultaneously. Then we have the light pulse coming from B reaching observer, Earth observer, all right in the middle at the same time because they travel the same distance. So observer O says A and B were hit simultaneously, and the light pulse coming from B reaches observer O prime first, and then the light pulse coming from A approaches reaches observer O prime. So O prime observer will say B prime was hit first, then A prime. So an event that appeared to be simultaneous in the Earth reference frame appears to be not simultaneous in the observer in the inertial reference frame that is moving with constant velocity v with respect to the Earth reference frame. Alright, so simultaneity is not an absolute concept and it depends on the time.